Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 19th, 2025, just yesterday. It introduces a self-evolving reinforcement learning framework that lets a single vision language model train itself on unlabeled images, boosting accuracy on tough visual reasoning benchmarks, for example from about 31% to about 47% on one model, while sharply cutting hallucinations. The paper is titled VisPlay, Self-Evolving Vision Language Models from Images. And, as we will see later, the implications for how we train multimodal models are quite significant. Figure 1 makes the core claim concrete. The self-evolving setup keeps pushing accuracy upward across several training evolutions, while a standard reinforcement learning baseline stays flat. Here, an evolution just means one full cycle, where the model generates new questions, answers them, and then updates itself. The dashed blue line shows the baseline trained with human-labeled data that plateaus around the mid-40s. The solid red curve for VisPlay without labels climbs from the mid-40s toward the mid-50s, so each evolution adds a bit more average accuracy across 7 datasets. This widening gap visually supports the idea that unlabeled images alone can drive substantial gains when the questioner and reasoner co-train. Figure 2 shows how the self-play loop actually runs, turning unlabeled images into training signals. The left block is the image-conditioned questioner, which takes a table-style picture and proposes several possible questions about it. Those questions, plus the image, go into the Multimodal Reasoner, which samples multiple answers so the system can measure uncertainty and do majority voting. The lower arrows then indicate 2 alternating pipelines, one that updates the questioner and one that updates the reasoner. Figure Table 1 turns that pipeline into numbers, showing that self-play consistently boosts accuracy across all 3 vision language models. Across 7 benchmarks, the average score for the smallest model climbs from about 31% to about 47% by the 3rd iteration. The challenger baseline, which uses an untrained questioner, already helps, but iterative VisPlay adds a clear extra jump. Hallucination on Hallusion bench drops dramatically, with the compact model leaping from roughly 33% to about 95% correctness, which shows that the self-generated supervision is not just louder, but also more reliable. Figure 3 shows that as the system trains, the questions steadily become harder, while the models keep getting more accurate. The orange curves track question difficulty, which rises quickly and then continues to edge upward across training steps. The blue curves show problem-solving accuracy, and they climb alongside difficulty rather than collapsing. This pattern appears in all 3 models, so the questioner and reasoner co-training seems stable, even when the questions grow more challenging. Table 3 makes a strong point. Self-play on unlabeled images matches human-supervised training on accuracy while greatly cutting hallucinations. The table compares standard group relative policy optimization, which uses human-labeled Vision 47K, with VisPlay after 3 iterations on the same 2 QN vision language models. Across general understanding and visual math tasks, the averages stay very close, yet the Hallusion bench scores jump from roughly the high 60s into the low 90s under VisPlay. Alright, the key takeaway is that VisPlay shows vision language models can teach themselves from raw images alone, reaching human-supervised accuracy while slashing hallucinations. More broadly, it hints at a future where multimodal systems grow by continuous self-play instead of expensive labels. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.